Hello, everyone. We're going to take a look today at how to do your results section, your predicted results section for our research proposal. And I think you'll find this really helpful. So let's go ahead and take a look at what the results section is. I'm not putting this into a regular presentation mode because I'm going to be writing on these slides. So in your results section, you're going to predict what you would expect if your study produces a significant result. So if your hypothesis is supported. And you will graph the predicted result in APA style. You'll use two graphs if you have two dependent variables. You're going to describe the graph objectively, just facts. I'll be showing you all of this. And no interpreting data. And this is going to be very short. So it's you might have as few as 2 sentences in this, but the graph is very important. So keep looking here. And just one more kind of informational slide before we get into graphing this. So first off, you might be wondering, how am I going to predict my results? And so this is related to your hypothesis. So if you hypothesize that condition A would have higher scores on the DV than those in condition B, then that's going to be your what your graph will look like. Or if you hypothesize that whatever it is you're measuring will increase over time, then that will be related to your hypothesis. And I think that most of you in this class will be using bar graphs. And so that would be right here. And so that's what I'm going to demonstrate first. And then I'll go through and use line graphs. And we've already seen scatter plots in our chapter on correlations, so I won't show those again. And then I'm going to plop it into the Word document, into the template, and write it up, and you'll see how straightforward this is. So we're going to go through a number of hypotheses and do a few of these. So beginning with this hypothesis, Doris, this is an actual hypothesis from last semester. Doris hypothesized that women who had experienced a rigorous puberty ceremony would have a lower subjective experience of menstrual pain than women who had a less rigorous puberty ceremony. And so I've already, in this case, told you what the dependent variable is. The dependent variable is this subjective experience of menstrual pain. And in this case, we see that it's going to be lower. This tells you the direction of the hypothesis. And so now we can look at who our groups are. So first, we're looking at women who experienced a rigorous puberty ceremony and women who experienced a less rigorous puberty ceremony. And so what the actual independent variable is the rigor of the puberty ceremony. And so you can see rigorous, less rigorous. And that's the only difference in those two statements. So that's our independent variable. So let's write that in. Rigor of puberty ceremony. And we'll put in condition A, rigorous. Condition B, less rigorous. And I just want to make note of one more thing here. The hypothesis in this case is going to be that condition A is lower. They're going to have lower menstrual pain than condition B. And so how are we going to graph this? So let's go ahead and get our drawing tool out, and I'll draw in this first graph. And we're going to be using a bar graph. And so I'm going to demonstrate this for you. Your bar graph will have a y-axis vertical, an x-axis horizontal, and always on the x-axis, you're going to put your two conditions of your independent variable. So we're going to write here rigorous and less rigorous. Notice we're not writing a lot of words here. We want our graph to be really simple. And so we're going to be just keeping as few words as possible and clarifying it via notes or the title. We'll see now that our DV, menstrual pain, is going to be rated from 20 to 60. So on the y-axis, we're going to write menstrual pain. And we're going to mark our numbers 20 to 60. We'll just mark it in increments. So we'll go 20, 30, try to get these even, 40, 50, 60. And so these are our rates. And so in order to know how to draw the bars, first of all, we know that A is smaller than B, so the rigorous is going to have less menstrual pain than the less rigorous. So we want a shorter bar here. So let's go ahead and say that maybe women get on average in this 40 range. So the less rigorous ceremony, they're going to have average menstrual pain, maybe about 40. So we're going to put the mean at approximately 40. And maybe we'll expect this rigorous condition to be a little less. It won't be much less because we're working with means. Mean approximately 35. And now we have some numbers to work with. But this still isn't a perfectly clear graph because we need to now go ahead and title it. Let me see if I still have a box here for a title. No, I don't. So I'm going to go ahead and get a text box here. And so here is a text box. I'll put it right here. And I'll show you how to write a title in very nice APA style. I think I'm going to move this maybe off the screen for a minute. So APA style requires that every figure be numbered. And even if it's a graph, they want you to call it a figure. So let's go ahead and write in here, figure 1. Whoops, figure 1. This is our first figure. And now we just single space here, and we use italics to give this a very specific title that includes both the independent and dependent variable. So let's go predicted. Let's be very clear that these aren't actual results. Predicted average menstrual pain for women who had rigorous and less rigorous puberty ceremonies. And so this isn't beautiful. When you do this yourself, you're going to do it much more neatly than I did on this screen. But this is the idea of exactly what your graph is going to look like. So let's do a second example. Hypothesis. Fiona hypothesized that people who are ostracized in a game of cyberball will have lower pro-social behavior than people who are not ostracized. And you can see here that I already wrote the DV. This will be on our y-axis. And so I'll put the y here. And you can see that this is the dependent variable. So I'm going to just underline it in black, pro-social behavior. And now we look at our direction, lower. So we know that A will be lower than B. And here are the groups that we're comparing. People who are ostracized in a game of cyberball and people who are not ostracized. And so the only thing that's different in these two people is that one group is ostracized, the other group is not ostracized. And so this is what makes our independent variable, ostracism. And we have condition 1, or condition A, ostracized. And condition B, not ostracized. And if we go to the bottom here and write our direction, we know from that word lower that we already put a box around that A is going to be lower than B. So let's go ahead and make another bar graph. So here is our basic y-axis and our x-axis. And I'm going to write our two conditions here, ostracized and not ostracized. Notice I'm not writing everything out. I'm not writing people. I'm not writing any of those other kinds of things, just the two conditions. I'll extend this bar a little bit. And over here on the y-axis, we're going to have pro-social behavior, but I'm going to write down what we're actually measuring here. We're measuring minutes helping. So let's write that very clearly here. Minutes helping. And I'm not sure how many minutes this might be, because remember, we're not gathering data, we're just predicting. But I can imagine that someone might have as few as 0 minutes, and maybe at the most 10 minutes. And I'll put 5 in the middle here. And so they're helping someone who is lost. So I think a typical person on a normal day might be willing to help for 5 minutes. So I'm going to put not ostracized, our typical people helping for 5 minutes on average. Mean approximately 5 minutes. I think if they're ostracized, they're going to help quite a bit less, and some people won't help at all. And I'll put maybe on average, mean 2 minutes. Notice now for our bar graph that we have some space between these two. We always need to have space indicating that these are two distinct groups. I think I'm going to add a clarifying note here on the minutes helping. So let's go ahead. I'm going to copy the title here so I don't have to do that all over again. I'm going to paste it onto here. So let's go ahead and rewrite this title. So we're going to leave the words predicted average there because this is how it will start. Now in this case, we're measuring not even average minutes. If we are measuring average, predicted average number of minutes spent helping by people who were ostracized or not ostracized in a game of Cyberball. Notice that all the letters are lowercase except the name of the game Cyberball. Now, I think minutes helping might be a little confusing. I don't know for sure, but I'm going to put a little note there just to make sure that it's clear. I'm just copying this text box, but I'm going to change it out. So I'm going to erase all this text. And I'm going to write with italics notes. With italics notes. And I'm going to put this little 1 here, and I'm going to write out minutes the 1 is not italicized. I'm going to fix this 1 in a minute and make it elevated, but I'll do that in a moment. So I'm going to write minutes helping indicates the number of minutes each person spent helping an individual. Let's just write it even. It's just a person who appeared to be lost. This is the proxy measure for pro-social behavior. All right, now I've clarified this, but let's do a little something else. This is just a note, so we're going to actually make it kind of a smaller text because it shouldn't be as large as the title. So there I've just shrunk the text. We're going to turn this 1 into super text by going to the font, the button, the arrow on the lower right corner of font, and click superscript. And now I have that indication that it's a footnote. And then we want to make sure that we put right here a little one also, so that this can be seen that this references this footnote. And if you had more notes, then you would indicate those in a second note. It would just continue the same paragraph, but a second note. So now we have another figure, and I think this is pretty clear. So let's go on to a third example. In our third example, we have Clara, who hypothesized that people who change their clocks in fall will experience higher seasonal depression than people who do not change their clocks. So in this case, we can see again the dependent variable, seasonal depression. We can see that it's higher, that the people in condition A who are listed first will have higher depression. And we can see that we're talking about people who change their clocks in fall and people who do not change their clocks. And so the only difference is the changing of the clocks. That is our independent variable. And so let's put clock change or time change or something like that. We can always clarify the words, and let's put condition A. And we're going to say change clocks. And condition B, no clock change. Now, I think this is going to be clearer if I change the wording up here and write clock change and then no clock change. That feels a little bit cleaner to me. Let me just organize that so it's a little easier to see. And we can see here that A, the people who change their clocks, are predicted to be higher in seasonal depression than condition B, those who don't change their clocks. So let's go ahead and write the graph. We should be getting a little bit good at this right now. Coming up, we'll be getting good at it. So we know that on our y-axis, we have the dependent variable. And so let's put on here depression. I'm not going to write seasonal depression because that's too long and we can write it in the title. And our scale says 0 to 20. So let's put 0 to 20 with 10 in the middle. On the x-axis, let's put our two condition, clock change and no clock change. I think that's pretty clear. And so I think that the level of depression for a typical person might be around 10. I'll put this under no clock change. Nice wide bar, and I'll write the mean is approximately 10. And then the clock change is expected to be higher. We see that here, higher, higher. So let's make this a bit higher. We don't know how much. We're just predicting. And so the mean may be 12. And I'm using this little arrow to mean approximately, because we're just predicting. And so now we can get a title for our graph. So let's write figure 1, predicted average. And what is this? It's predicted average, average level of depression for people who change clocks and people who do not change clocks in fall. And I think that's good right there. I don't think we need a note. Maybe I'll add the word seasonal here to keep it clear that we're talking about that. So we want to be as clear as possible here. I've added fall. That's different from here, so we can see that. I think that's a good title. Let's go on and do one more. Jerome hypothesized that older people in nursing homes who have bird feeders outside their window will have higher levels of well-being than older people without bird feeders. And I've already identified for us the dependent variable. This is what we're counting, what we're measuring, what's always going to go on the y-axis. And our direction higher indicates that condition A will be higher than condition B. So let's look at the difference. We have older people in nursing homes who have bird feeders outside their window and older people without bird feeders. So I see that the only difference in here is whether or not they have a bird feeder. So our independent variable is bird feeder. And let's write feeder, condition A, feeder. I'm using the shortened word so it can fit nicely on our bar. Condition B, no feeder. And we've already stated that we're expecting A to be greater or higher than B. So let's go ahead and draw this for our last graph. On the y-axis, we're always going to put our dependent variable. And so let's write well-being. And we have a scale from 1 to 30. So let's go our 1 here, our 30 here, and we'll put 10 and 20. On our x-axis, we'll have our two conditions. We'll have feeder. And any questions we can clarify, of course, when we write our title. And no feeder. We know that A is going to be greater than B. And, you know, I think people who are in nursing homes, maybe they really don't feel that great all the time. I think that's possible. And I'm just having a concern that my screen isn't properly sharing because I don't see the green line around it. And I certainly hope that's not true. So I'm going to finish this slide and see if I can figure it out. Feeder versus no feeder. And so I think people in general without feeders, just a typical person might not be feeling that great. They're in a nursing home, maybe 10, you know, compared to the total that people might have. But maybe these bird feeders make it a little bit better. And so maybe we'll put a 10 here and maybe something like a 13 here. And then we can give a title to our presentation. And the title that we'll give this presentation, let's go ahead and copy what we've been doing. And so figure 1, we're always going to start with predicted average for this. So the predicted average level of well-being, notice I'm putting the dependent variable here, that's what we're counting, for older people in nursing homes who have or do not have a bird feeder outside their window. And I think that's a pretty clear title, and this is just fine. This is well done. So this is one type of graph. This type of graph is called a bar graph, and this is, I think, what most of you will be using. I'll show you a couple examples of another type of graph just in case. So some of you may be having, I'm going to skip ahead. Some of you may be having measures that cross time. And in that case, you would be looking at a different kind of scale. You'd be looking at a line graph. And so let's go ahead. I'm not sure what happened there. This is a little bit too small. Let's go ahead and see what that would look like. The hypothesis here is that Corona hypothesized that people's level of conscientiousness would increase with each decade of life. So that people would become more conscientious as they got older in years. And so our independent, we're going to be measuring conscientiousness on a scale from 0 to 100. And our independent variable is actually going to be decade of life. So like in their 20s, their 30s, their 40s, that's what we're going to see. And we are expecting an increase as stated in the in the hypothesis. So once again, for a line graph, we have on the y-axis the dependent variable, in this case, conscientiousness. Zero to 100 with 50 in the middle. On the x-axis, we're going to have the decades. So we're going to have people in their 20s, their 30s, their 40s, their 50s, and 60s. And let's say that's as far as I went. And so I'm going to give this a little title that says Decade of Life. And let's go ahead and put some marks. So in a line graph, we're not going to have bars. So we're just going to put points. And let's say that we start average conscientiousness. By the way, conscientiousness means like taking your responsibilities seriously, paying your bills on time, doing your work before pleasure, making sure that your grandparents have wood, making sure there's gas in the car and that the tires are full. All those kinds of things are conscientiousness. So let's say people in their 20s are maybe a little bit below the midpoint. They haven't quite learned it that well. By the 30s, that probably increases a lot as they begin to have children and they have to be more responsible, maybe a bit more in their 40s, maybe in their 50s, gets a little bit higher, maybe in their 60s, they're really on top of their game. So it's a line graph because we draw a line to connect these points. So that's what we predict. And in this case, the title would look much as it did before. And it would go on top, but I'm going to put it on the bottom because I have some words written on top. And so we would have predicted average conscientiousness level. Conscientiousness level across decade of life. And this, of course, would actually go up on top. It's just going to compete a little bit with those words. Now, let's take a look at a second hypothesis that will be a little bit more complex. So Sarah hypothesized that students who have a particular intervention would have a greater decrease in the number of disruptive behaviors in a classroom each week compared to a control group. And so we have for our IV whether they've had an intervention or no intervention, and we're measuring disruptions by counting incidents on a classroom video. And it says here that we're looking for our people with the intervention to have a greater decrease. So we're looking for a decrease in condition A. So look at how we're going to do this. We're going to still have the same measure for the dependent variable. I'm going to bring it a little lower so I leave room for the title this time. And so we are just looking at disruptions. And I don't know how many disruptions might occur in a classroom, but let's say The range is maybe from 0, which seems extremely unlikely, to 30. 5 a day, maybe on average, I don't know. And so let's put 10 and 20 here. We're just predicting. And then across the y-axis, in this case, the time frame that we're working with is week. And so let's put weeks as our label. And we would have week 1, week 2, week 3, week 4, week 5, and week 6. Now, in this case, we have 2 groups. We have the intervention condition and the no intervention condition. So we're going to add a little key. We're going to use for our intervention condition something that looks like this: solid dots connected by lines. And so this is going to be intervention. We had a little run out of space there. And let's say our other condition will mark with open dots connected by lines. And this is going to be no intervention. And so let's go ahead and draw these. Let's say that in both situations, the group started right around 20. So here's our I need to line that up with week 1. So I'm going to erase that dot and redo it. So let's say here is both groups starting at about the same level. In fact, maybe this group is up here. So now I'm going to take our intervention group, and it says they're decreasing. So let's say they've had the intervention, it's starting, maybe week 2 they go down. Maybe week 3 they go down a little more. Maybe week 4 was kind of a rough week, they went up a little. Week 5 they went down a little more. Week 6 up a little. But overall this is a decrease. And so let's connect these dots. In the no intervention condition, we have, I'm going to actually change the point of our first dot here. So in the no intervention condition, we don't expect to see a similar decrease. So let's say they started right about here. And in week 2, maybe they were slightly increased. Week 3, maybe they were right around here, right at the same level. Week 4, they jumped. Week 5, they were still high, and week 6 still high. And in this case, the line might look like this. And so the line crosses. And so you can see that this is how we would depict these data in the case when we have 2 competing pieces of information. And we would put the title like this. Figure 1, predicted number of disruptions in classrooms of students who had or did not have a particular intervention. And so that's what that would look like if we have a passage of time. And you'll notice in a couple more examples that passage of time could be weeks, as in this example, or could even be hours of the day, as in this example. And I won't go through those anymore because I want to show you how to use your template and actually write this up. So let's choose one of these. I'm going to choose a bar graph because I think this is more common. And I think I'm going to choose maybe this one. So this is what your template looks like that I created for you. Your template you can use like this. All you need to do is fill in, replace my writing with your own writing. And so what I'm going to do first is imagine that this is a nice, neat graph. So first I'm going to copy out the title and I'm going to replace what it says here with my title. Notice that there's no indent and this is left flush. So I'm going to just paste it in. And so now we have this ready to go. The title is all set. I've pasted it from my worksheet. Let me go ahead and get the graph. If you were really doing this, you would do a much neater and nicer job than I've done here. But I'm using my snipping tool in Microsoft Windows. And let me see if I can find it here. Here we go. And I'm just going to copy this image, even though this isn't the nicest, neatest one that I might actually present. So let's put it into our document. And I'm going to just go ahead and copy all of this empty space down to the next line. So to here, and I'm going to paste in my picture. And this could be extended to both margins. And yours would be much neater than mine is drawing on the screen, but this is what it would look like. Now we just need to change the text. So this is quite a simple process. We're going to reference the figure. We're going to describe our variables fully, and we're going to make sure that we have words that are indicating that this is a prediction. So I'm going to write figure 1 depicts the predicted results if the hypothesis is supported. Older people in nursing homes are expected to have significantly higher levels of well-being and now I don't like something about this. I want to clarify that older people in nursing homes who have bird feeders outside their windows are expected to have significantly higher levels of well-being than older people who have no bird feeders. Now we can write in some statistics here, or at least our general data. We're predicting that the ones who have bird feeders outside their windows, so right after that group, I'm going to put M is, I'll put equals approximately 13, and that I've gotten from the image below, are expected to have significantly higher, whoops, this needs to be moved to here. It needs to be right after the word well-being, significantly higher levels of well-being. The mean equals approximately 13 than older people with no bird feeders, for whom the mean is approximately 10. Now, in here, there's nothing else I need to say. If I have another dependent variable, I'll go down to here and I will write about the second dependent variable and include a second table. If I have no dependent variable, as I don't, I just get rid of this. All right, that's it. This is the predicted results section. If we had done a statistical test, we would describe that test here. What this would be actually a t-test. But we don't write that because we haven't done it. So this is it. You're just describing what this figure shows and including the figure. And so I hope that's helpful to you. There's an example and a template available. Let me show you where. What I recommend you do when you're working on your paper is that you go directly to this proposal assignments. Look where it is on the left menu. Click on it, and then you'll see all your key dates. You'll see your annotated bibliography assignment. Go down to proposal. And when you click on it, you won't see this. You will see this. And so you can see where your resources are. So this template that I just used is right here. This video will be right here. And an example would be linked right here. So I hope this is helpful to you. I'm going to end this now, and hopefully you've gotten what you need out of this. Let me know if you didn't, though. I need to support you very much as you move forward and have success writing your papers.